Assalamu alaikum dear students and welcome you all for today's science class. Let's start with the talk of the day. And today's talk of the day is if you are not willing to learn, no one can help you. If you are determined to learn, no one can stop you. Yes, determination is about staying focused on a goal. And as long as you have a goal, you can create paths to that goal, moving even closer to success you want. And keep remember one thing, winners never quit and quitters never win. So keep yourself going with full determination and hard work to reach your goals, right? As you know, we had discussed properties of metals in detail in our previous lessons. And you know that because of having multiple properties, the metals are considered unique elements in our universe and are a part of our everyday life, right? So, students, as there is a wide range of metals, metals can vary greatly from many others in terms of their appearance, properties, uses, and reactivity. If you take an example of gold, then we observe that gold is yellow in color, gold is relatively hard, gold is an unreactive metal. But if you observe another example that is of potassium, then you will see that potassium on the other hand is gray in color, it is relatively soft metal and it is highly reactive metal. So we can actually organize these metals according to their reactivity. And this arrangement or this organization of metals according to their reactivity is known as reactivity series. Now, how can you define reactivity series? Metals can be arranged in a sort of league table according to the way they react. This league table is called reactivity series, right? This league table or arrangement of metals according to their reactivity is called reactivity series. Now the question is, what is league table? League table is basically a list of things that are arranged in order from best to worst. And in case of reactivity series of metals, league table shows a list of metals that are arranged in order of their reactivity from high reactive metal to low reactive metal, right? This slide shows reactivity series. The metals, if you see in this list, the metals which are highly reactive, they are placed at the top of reactivity series. As you see, potassium is placed over here at the top of reactivity series. In this list, you see potassium at the top. So why it is placed at the top? Because it is highly reactive, right? The reaction of metals gradually become or less reactive or less violent as we go down the series, right? The reaction of metals gradually become less reactive or less violent as we move down the series. Clear? So least reactive metals, they are placed at the bottom of the reactivity series. As you see in this slide, that gold is placed at the bottom of the reactivity series because it is unreactive metal, right? It is unreactive at all. So in this series, you will always see most reactive metals at the top and the least reactive metals, they are placed at the bottom. This list, this list was created experimentally by studying the reaction between metals with water, acids, and air, right? The reactivity series allows us to predict how metals will react, right? Let's have a look at reactivity of different metals with water, acids, and oxygen. When metals react with water, they produce alkali and hydrogen gas. When any metal, it reacts with water, they produced alkali, that is hydroxide, alkali and hydrogen gas. Let's see an example of potassium, reaction of potassium with cold water first. Potassium, as you know, it is highly reactive metal. That's why you see potassium is always placed at the top of the reactivity series, right? So potassium is highly reactive metal, so it reacts violently even with cold water. Potassium reacts with even cold water violently, right? And produces potassium hydroxide, and hydrogen gas is also released, right? Reaction of potassium with cold water is violent reaction, right? And it produces alkali. That the name of that alkali is potassium hydroxide, and it also produces hydrogen gas. As potassium, I have told you, it is highly reactive metal. That's why you see it is placed here at the top of the reactivity series. Clear? Now let's take an example of magnesium. Magnesium, when it reacts with cold water, so that reaction is too slow. When magnesium reacts with cold water, that reaction is too slow. Reaction of magnesium with cold water is too slow, and it produces magnesium hydroxide and hydrogen gas, but that reaction is slow reaction, right? But when magnesium reacts with steam, then magnesium reacts violently with steam. With cold water, magnesium reacts shows a slow reaction, but when magnesium reacts with steam, it reacts violently. Basically, magnesium burns in steam, right? And produces magnesium oxide and hydrogen gas. So this reaction is vigorous. Vigorous means violent reaction. Reaction of magnesium with cold water is slow. Reaction of magnesium with steam is violent reaction, right? Okay, let's take an example of gold now. If you look at the reaction of gold, then you will know that gold neither react with cold water nor with steam. Gold neither react with cold water nor with steam, because gold is an unreactive metal. As gold is unreactive metal, that's why it is placed at the bottom of the reactivity series. As you are seeing in this slide, that gold is placed at the bottom of the reactivity series over here, right? As you know, gold is an unreactive metal. It does not react with anything. So gold does not corrode and stays shiny, right? That's why gold is good in making jewelry. Gold is used in making jewelry, right? Because it is an unreactive metal and it can stay shiny for a long time. Okay, now let's move towards the next slide. Now we will see the reaction of metals with dilute acids, right? When metal reacts with dilute acids, then metal salt will be formed, and hydrogen gas will be released. When metal reacts with dilute acids, then metal salt will be formed and hydrogen gas is produced. Clear? If you see reactivity of metals through this series, you will know that if you see this slide, potassium, sodium and calcium, they react violently with dilute acids. Potassium, sodium and calcium, they are highly reactive metals. They show violent reaction with dilute acids, right? And that's why, because of this reason, we should not put these metals into acids, because it is highly dangerous to put these metals into acids because they show violent reaction. Potassium, sodium and calcium, they are highly reactive metals, so we shouldn't put these metals into acids because they are highly reactive metals and they show violent reaction even with dilute acid, right? What is dilute acid? Dilute acid is that in which large amount of water is mixed in an acid, right? The amount of water is large and it is large amount of water is mixed in acid. That is dilute acid. So even in dilute acid, potassium, sodium and calcium, they show violent reaction. But if you see over here, magnesium, zinc and iron, they are fairly reactive metals. And magnesium, it shows moderately fast reaction in dilute acid. If you see the reaction of zinc and iron, they show slow reaction with dilute acid. But if you see over here, these copper, silver and gold, they show no reaction with dilute acids, right? Clear? And if you compare, if you see the comparison of reaction of metals with water or steam and acids, then you will notice through this table that potassium, sodium and calcium, which are highly reactive metals, they react even with cold water, right? Because they are highly reactive, that's why they react even with cold water. And they show violent reaction with dilute acids. If you observe magnesium, zinc and iron, they react with steam, right? They react with steam. And magnesium, it shows moderately fast reaction with dilute acid, while zinc and iron, they show slow reaction with dilute acids. But if you observe the reaction of copper, silver and gold, then they show no reaction with water and steam. They show no reaction with dilute acids. Clear? So according to their reactivity, the most reactive metals, that's why they are placed at the top. Then fairly reactive metals are placed. And finally, unreactive metals are placed at the bottom of the reactivity series. That's why you are seeing here potassium is at the top because it is highly reactive. Then comes sodium and calcium in this list. They are also reactive. And if you see at the end of the list, the least reactive metals are present. And then unreactive metals are present according to their reactivity. Clear? Okay. Now I will move towards the next slide. Now we will see the reaction of metals with oxygen, right? Most metals will react with oxygen. Some metals react faster than the others, and some may react very slowly or not at all, right? So the reaction of metals with oxygen is again like highly reactive metals, they react faster than the others, and some metals they react very slowly, and some metals they are still unreactive even reacting with the oxygen. For example, if you take an example of any metal, when any metal it reacts with oxygen, the product is metal oxide. When any metal reacts with oxygen, metal oxide is produced, right? Magnesium, for example, burns in oxygen with a bright flame. The magnesium reacts with oxygen, right? The magnesium reacts with oxygen to produce magnesium oxide. Clear? Metal oxide. Here, what is the metal oxide? Magnesium oxide is the metal oxide. When magnesium reacts with oxygen, it produces magnesium oxide. Sodium and potassium are the most reactive metals. Metals such as gold and silver do not react, so they do not corrode and stay shiny, right? Okay, if you see this table, this is again reactivity series, list of reactivity series. If you see this league table, you will come to know that potassium, it reacts vigorously, even in air, means oxygen. Sodium, it also reacts vigorously to form metal oxide. That's why they are placed at the top. Then calcium, magnesium, aluminium, zinc, and iron. They burn with decreasing vigor. Means they react quickly, they react fastly, but less vigorously than sodium and potassium. Sodium and potassium, they burn vigorously. Calcium, magnesium, aluminium, zinc, and iron, they react quickly but less vigorously as compared to sodium and potassium. If you observe this list, you will see that lead, copper, and mercury, they react slowly with air or oxygen, right? And what about silver and gold? You are seeing through this table that silver and gold, as they are unreactive metal, so they do not react with oxygen also. So they are placed at the bottom of reactivity series. Clear? So this is how reactivity series ranks metals according to their reactivity, right? Most reactive metal at the top, least reactive metal at the bottom. Clear? Okay. One way to remember this order of metals in reactivity series is to learn this funny sentence. If you want to learn this order of metals in reactivity series, you have a funny sentence to remember it in an easy way, right? What is that funny sentence? Please send Charlie's monkeys and zebras in lead cages securely guarded, right? P in please is for potassium. S in send is for sodium. C in Charlie is for calcium. M in monkeys is for magnesium. A is for aluminium. Z is for zinc. I is for iron. L in lead is for lead. C is for copper. S is for silver. And G in guarded is for gold, right? So this funny sentence will help you to remember the list of metals placed in order of their reactivity series. Isn't it interesting and easy way to remember? Yes. Okay, students, what we have learned and discussed so far, that reactivity series is the list of elements in order of decreasing reactivity, right? So most reactive metals are placed at the top and least reactive metals are placed at the bottom. The reaction of metals gradually become less reactive as we move down the series. If you compare reaction of metals with water, acids, and air, then you will notice that potassium And sodium, they react vigorously in air to form metal oxides. Potassium, sodium, and calcium, they react even with cold water. And potassium, sodium, they react, they show strong reaction with dilute acids even, right? Then if you see in the list that the calcium, magnesium, aluminium, zinc, and iron, they burn with decreasing vigor down the series, right? Then magnesium, aluminium, zinc, iron, they only reacts with steam. They do not react with cold water, they react with steam. But they show strong reaction in dilute acids. If you move down the series, then you will see that lead, copper, and mercury, they react slowly in air with oxygen. They show no reaction with water. They react with concentrated acids. They do not react with dilute acid, they react with concentrated acid. But if you go down the series at the end, then you will see silver and gold over there at the end of this series. Silver and gold, they do not react with air. They do not show any reaction with water. They do not show reaction with acids also because they are unreactive metals. That's why they are placed at the top, right? So this is how metals are arranged according to their reactivity in reactivity series. Clear? Okay, students, now if you have any questions, any query regarding today's lesson, you can ask now. Now it's time for question answer session. Are you ready for it? Okay, my first question is define reactivity series. Second question is name one metal that reacts with water and acids. Third question is name three metals that should never be put into acid. Fourth question is what are unreactive metals? Fifth question is why unreactive metals are good for making jewelry. Next question is why is potassium at the top of reactivity series? Next question is what happens when a piece of sodium is dropped into the water? Next question is what happens when a gold ring is left in a weak acid? Okay, it's homework time now. And what is your homework for today? You have to do question answers of Test Yourself of Unit 3 of page 33 and 35 of your textbook on your science copies, right? So think and write question answers of Test Yourself of Unit 3 of page 33 and page 35 of your textbook neatly and properly on your science copies. Clear? Okay, this is all for today. Hope you have understood today's topic well. See you later with the next topic. Till then, goodbye from my side and thank you all.